Assalamualaikum and a very good day to our lecturer and fellow classmate. You are now tuning in to our Physics 260 radio broadcast presentation, and today we will be sharing an interesting case study on radio broadcasting. Throughout this presentation, we will explore the basic concept of the topic, discuss its real-life application, and highlight the benefits it brings to society and technology. And finally, take a look at its future development and potential advancement. We hope this presentation will help you gain a better understanding of how physics continue to shape the world around us.
Now I will present about radio broadcasting. Radio broadcasting is the transmission of audio signal using electromagnetic wave. It is one of oldest form of wireless communication and has been used for over a century. Radio allows information and entertainment to be delivered over long distance without physical connection. Common use include music, news, educational program, and emergency announcement. Because of its wide coverage and easy accessibility, radio remains an important communication. Now let's look at the basic concept of radio broadcasting. Radio broadcasting is used electromagnetic wave to carry information from a transmitter to a receiver. This wave travel at the speed of light and can move through air without physical medium. To send audio over long distance, the audio signal is combined with high frequency carrier wave through a process called modulations. The two main types of modulation are AM amplitude modulation and FM frequency modulation. At the receiver, the signal is demodulated and converted back into the sound.
Radio broadcasting works. So first, sound such as music or speech is converted into electrical signal. This signal is then combined with the high frequency carried wave through a process that called modulation. So modulation allows the signal to travel over long distance. There are three main types of radio broadcasting. So the first is amplitude modulation or AM. So in AM radio, the amplitude of the carrier wave change according to the audio signal. AM signal can travel very far, especially during at night, but they are more affected by noise and interference. The second type is frequency modulation or FM. So FM change the frequency of the carrier wave instead of its amplitude. As a result, FM provides better sound quality and is less affected by interference, making it suitable for music and external broadcasting. And the last type is digital radio, which convert the audio into digital data before transmission. These provide clearer sound quality and additional services such as text information. After modulation, the signal is transmitted by an antenna as a radio wave. This radio wave travels through the air and received by a radio receiver, which demodulates the signal and convert it back into sound. Let's introduce about the application of radio broadcasting. So radio broadcasting has many applications. It provides entertainment through music, talk shows, podcasts, and sport commentary. It is also important during emergencies because it can help to deliver warning and critical information. In addition, radio is widely used to provide news, traffic updates, weather forecasts, and government.
I will present the benefits and challenges of radio broadcasting. Radio broadcasting offers several important benefits. First, it has a wide coverage area and carries a large audience over a long distance. Second, is a low-cost communication method, making it affordable for both broadcasters and listeners. Radio can also be accessed in remote areas where internet connectivity may be limited or unavailable. Furthermore, radio play an important role during emergency by providing timeline information, warning, and update to the public. However, radio broadcasting also faces several challenges. One challenge is signal interference, which can affect the quality of transmission and reduce listening quality. Another challenge is the low sound quality of AM broadcasting compared to modern digital technology. Radio stations also face strong competition for streaming service, podcasts, and other digital media platforms that are becoming increasingly popular. In addition, frequency spectrum congestion occurs because many radio stations compete for limited radio frequency. Radio broadcasting remains a reliable and accessible communication technology, although it offers many benefits such as wide coverage and emergency communication. It must continue to adapt and improve to overcome these challenges.
We'll discuss the future development of radio broadcasting technology. First is radio broadcasting. This development combines traditional digital terrestrial transmission with 5G mobile networks. The advantage is that listeners can enjoy higher quality and uninterrupted audio even when moving between locations. Second is AI integration. Artificial intelligence is becoming increasingly important in broadcasting. AI can provide hyper-localized weather and traffic updates, making information more relevant to specific areas. It can also automatically generate transcripts, improve accessibility, and even create dynamic content based on listener preference. This helps station operates more efficiently while improving user experience. Lastly, there is targeted digital advertising. Instead of relying only on traditional radio ads, stations are now integrating with IP-based streaming platforms. This allows advertisement to be more personalized based on listener interest and behavior, making marketing more effective and relevant. Radio broadcasting has evolved significantly, and its future continues to expand through innovations such as hybrid broadcasting, artificial intelligence, and targeted digital advertising. Furthermore, radio remains highly relevant despite the growth of social media and streaming services because it provides real-time information, entertainment, and emergency communication. The integration of smart technologies, internet-based streaming, and data-driven systems may transform broadcasting into a more intelligent and globally connected medium. Therefore, the continuous development of broadcasting technology is essential to meet changing audience demands and ensure that radio remains an important communication platform in the digital era.